We're going to walk through an example where we are going to find the volume of a solid of revolution by revolving a region about the line x is equal to a. In this problem, we are going to be using cylindrical shells. Our region is bounded by the curves y is equal to x minus x squared and y is equal to 0, and we're going to be revolving this region about the line x is equal to 2. The first thing that you want to do when solving this type of problem is to graph the curves. I've already done that just to make things easier. And I've also graphed the line that we're going to be rotating our region about. The formula that we're going to be using is the standard formula for using cylindrical shells for rotating a region about a line that is parallel to the y-axis. We're integrating with respect to x because the width of our cylindrical shell is equal to dx. The first thing that we want to do is find the x intersection points, and those are going to be this point right here and this point right here. We can find that by just setting our two curves equal to each other. We have y is equal to x minus x squared, and we're going to set that equal to y is equal to 0. We can factor out an x, and this leaves us 1 minus x is equal to 0. So we get that x is equal to 0 and x is equal to 1. We'll go up here and label this point 0 and this point 1. Now what we need to do is find r and y. R is the distance from our curve to the line that we're revolving about. So this distance right here is going to be r. To find what r is equal to as a function of x, we need to notice that this distance right here is equal to x. Because this distance here is equal to 2, we can say that x plus r is equal to 2, and that gives us a formula for r, and it's equal to 2 minus x. Y then is this distance right here that I'm marking in red, and it is the distance from the x-axis to the curve. We can just write down that y is x minus x squared. Now we can go ahead and set up our integral. We'll write down the formula first. Our volume is 2 pi, the integral from a to b, r times y times dx. We'll substitute in that a is 0 and b is 1. Our radius is r is equal to 2 minus x. And then y is equal to x minus x squared, and we have dx. Before we integrate this, we are going to multiply out what we're integrating. We can use the FOIL method. Multiply the first terms, which is 2x. We'll multiply the outer terms, which is minus 2x squared. And then the inner terms gives us minus x squared. And then our last terms gives us plus x cubed dx. Looks like we can combine our x squares. So let's do that before we integrate. This gives us 2x minus 3x squared plus x cubed times dx. Now we can go ahead and integrate. Our first term is 2 times x squared over 2, so the 2's will cancel. And then minus 3x cubed over 3 plus x to the 4th over 4. And we're evaluating this from x is equal to 0 to x is 1. Let's see what we get. We'll substitute in that x is 1. So we get 1 minus 1 plus 1/4. And then when we substitute in x is 0, we get 0. So this is really nice. This just turns out to be 2 pi divided by 4. So we get an answer of pi divided by 2. And that tells us that our volume is equal to pi over 2.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.